Okay, in this lesson, we're going to be working with our product powers of exponents. So when we multiply powers that have the same base, we can add their exponents. Most important thing to understand about this, they must have the same base number. So remember that base number is that number that's that bigger in size number. It's the number that's occurring the number of times stated by the exponent. They must have the same base number in order for this rule to apply. So the rule is that when we have the same base number that have exponents, we're just going to go ahead and actually add their exponents. So why does that work? Well, if we were to look at this written out longhand or an expanded form, it would look like this. This would be 2 times 2. And then we have this times sign. And then this would be 2 times 2 times 2. Take note, how many 2's do we have? We have 1, 2, 3, 4, 5. So we have 2's, and there are 5 of them. How else could we have gotten that without actually writing it out longhand? Sorry, this is a multiplication sign. Is we could have added these two together. 2 plus 3 gives us that 5. Okay, so as long as the base number is the same, we can go ahead and add exponents when multiplication is involved between those two base numbers. Okay, so that's the shortcut without having to actually write it out longhand. Okay, so let's try some of these. So I have 2 to the power 4 times 2 to the power 5. So the first thing I check is, are my base numbers the same? Yes, they are. So we're going to go ahead and just add together 4 plus 5. That gives me 2 to the power of 9. So when we first start out solving these, they're just going to ask us to simplify it. Give us the 2 to the power of 9. We're not going to have to worry about necessarily solving it. If it says evaluate or solve, then we would go to that next step of finding out what 2 to the power of 9 is. Okay, so right now we're just practicing that basic step of finding what the new exponent is. Okay, how about x to the 3rd power times x to the 7th power? So first thing we check always, are the base the same? Yes, although it's a letter, it still is the base. So our base was x. And then because we were multiplying, we get to add the exponents. So 3 plus 7 is 10. Now, that's all the further that we could actually solve this one because we don't know what x is. We just know the x to the 10th power. Okay, we can't really solve it any further anyway. And let's try one more. We have -5 with no exponent times -5 to the 6th. Okay, so here's what we have to understand is that this, yes, although it is not in a parenthesis, it is still there. There's nothing else out in front of that -5 or that 5, that -5. We're going to think of it as a -5. Now, since there's not an exponent, there's how many -5's in this parenthesis? There is 1. So that's like saying there's an exponent of 1. No exponent means an exponent of 1 because there is 1 of them there. Okay, we'll deal with exponents of 0 later in this chapter. So we have to realize that just because there's 1 there, that the exponent is 1. Now, are our base numbers the same? Yes, they are -5. And we're going to go ahead and add these together. So -1 plus 6 would give me 7. So our final answer is -5 to the 7th power, making sure to put that -5 in a parenthesis. Okay, so I'm going to slide some out here for you guys to try. I want you to try them on your own and then check back to see what your answers are. So go ahead and pause your video, work your way through these, and then check back in just a couple minutes to see if your answers were right. Okay, so you should have gotten 6 to the 6th power, z to the 13th power, because that first z there is z to the 1st, and -1/2 to the 9th power. Okay, remembering when we're working with base numbers that are the same and we're involving products or multiplication, we can add the exponents to find out what the new exponent is.